So, today we will continue with 10 more problems dun sa ating HVAC-R. The last time, meron tayong 14 problems pero meron pa akong utang sa inyo na, tama ba? 15 problems, meron pa ako sa inyong utang na 4. Ngayon, let us continue with the 10 problems and then yung 4 na remaining will come out after this and then the notes you will after this din. Okay? So, ako i-release somewhere naka-PDF format. Now, let us go with problem number 1. So, 10 problems 'to, hatiin ko ulit ng tig 5. So, simple review na rin ito ng ating ref and aircon. Okay, ilabas ko lang dito yung notes ng ref and HVAC. Okay. Okay, extras. Ayan. So now, let us go with this problem. Problem number 1. A simple saturated refrigeration cycle for R12 system, okay? Ini-specify naman kung anong system 'yan. Operates at an evaporating temperature of minus 5 degrees Celsius and condensing temperature of 40 degrees Celsius. Now, kapag given yung graph or given yung tables, all you have to do is uh, have it on tables and then superheated, hanapin nyo dun sa graph. Ngayon, dito ibinigay na niya yung lahat ng values na kailangan mo. Now, for refrigerating capacity, ibig sabihin, yung capacity mo, yung QA, that is 1 kilowatt. Determine the volume flow rate of the refrigerant in cubic meter per hour. And at 40 degrees Celsius, ito daw yung mga nahanap niya. So, HF is at, ibig sabihin sa condenser na yan, that is 238.5 kilojoule per kilogram. Pag grinaph mo yan sa pH diagram, okay, nandun yan sa saturated line. And then at negative 5 degrees Celsius, yung Hg niya, ibig sabihin yung vapor mo is saturated. And sa value of 349.3 kilojoule per kilogram. Now, yung kanyang specific volume at that state is at 6.496 times 10 to the negative 2, raised to negative 2, cubic meter per kilogram. So, you are given ng specific volume. Ibig sabihin, that is volume per mass. Now, the enthalpy at the entrance to the condenser coming from your compressor, that is 372 kilojoule per kilogram. So, let us take a look at the graph. Pwede natin ito i-graph eh. Graph natin siya. Oh, this is pH. Okay? Now, as you can see, pwede natin i-graph siya ng ito, sa pH diagram. Diba nag-graph kayo niyan? Oh, wag niyo sabihin sa akin hindi kayo nag-graph niyan. Yari kayo kay Sir Euro. Now, from here, ibig sabihin, yung Hg mo dito at negative 5 degrees Celsius. Ito yung negative 5 degrees Celsius line. Okay? Negative 5 degrees Celsius, andito siya. Okay? And then, saan daw papatong dito? Entrance to the condenser. So, this is 0.2. Andito yan. Yung 372. This is 0.2. This is 1. And then, yung nandito, sabi niya, at 40 degrees Celsius, at this temperature nung iyong vapor, saturated, okay? Now, bababa siya dito. Ayan. Okay? So, itong part na ito, ayan. Ibig sabihin, simple vapor compression lang siya. This is 40 degrees Celsius. Now, pwede nating masolve yung kanyang value. Okay, anong hinahanap po dito, sir? Okay? What is needed, ibig sabihin yung volume flow rate ng refrigerant. Pero commonly, di ba ang binigay sa'yo dito, meron kang QA or refrigerating effect. M, refrigerant, multiplied to H1. Dito nang gagaling yun, di ba? QA. Sa part na ito. H1, tama ba? H1, dito yung 4. Minus H4. Now, ang binigay niya dito is 1 kilowatt. Pero saan manggagaling yung ating volume flow rate? Itong Q, wag na nating Q, 'di ba? Meron na tayong Q diyan. So palitan natin tong Q. This is volume flow rate ng refrigerant ang hinahanap natin. Now, how will we solve this? Okay, dito manggagaling sa mass. Pero ang mass mo, 'di ba, is equal to what? Volume times density. Tama ba ako? Volume times density. Pero excuse me. Pero ang binigay kasi sa'yo dito is simply yung iyong VG, tama? So dito kunin mo muna yung refrigerant mass flow rate ng refrigerant para makuha mo yung iyong volume flow rate ng refrigerant. Okay, pakita natin kung paano. So MREF equal to 1 kilowatt ang binigay sa'yo dyan. 1 kilowatt per H1 minus H4. So H1, nasaan na H1 mo dyan? Tignan natin. So this is H1. Ayun, H1. And this is H4. Kasi nandito siya HF eh. Okay? Equal lang yan. Okay? Constant enthalpy ang ibig sabihin. This is constant enthalpy line na pag nag-pass through ng iyong expansion valve. Okay? Nag-throttling. So that is 349.3 minus 238.5 kilojoule per kilogram. Now, mapapansin nyo that 1 kilowatt is equal to 1 kilojoule in every second. So, cancel mo yung same units. Kilowatt, kilowatt, kilojoule, kilojoule. Ito iakyat mo dito sa taas. Magiging kilogram per second. Now, what will be the answer ng MREF mo? So, 1 kilogram per second dapat yan. 349.3 minus 238.5. Okay. Pwede nang gawin mong ganito muna. Huwag mo muna i-simplify. This will be equal to 5 over 554 kilogram in every second. Oh, ang hinahanap natin is VREF. Okay? Volume flow rate of the refrigerant in meter cube per hour. So now, the volume flow rate of your refrigerant, ganito lang po kadali yan. I-multiply mo na lang ng VG. Yung, yung mass flow rate ng ref mo. Yan, para ma-solve mo siya. Yung volume ng ref. Kasi bakit, sir? Bakit? Tandaan nyo that density is equal to mass over volume. Ang density mo, 'di ba, equal yan sa ano? Density is equal to 1 over yung specific volume. O, di equal to sa 1 over specific volume. O, di multiply mo to in order for it to get the volume flow rate. Okay? That is equal to mass multiplied to specific volume, G. O, ayun, multiply mo na. So, that is 6.496 times 10 to the negative 2 meter cube per kilogram times 5 over 554. So, yung nagsusulat dyan, 554 kilogram in every second. May nagsusulat to, hindi ako to. Okay. Bahala kayo kung gusto nyong burain o ayaw nyo. Hindi ako nagsulat yan, ha? And then, please wag nyong pagtripan yung ating sinosolve. Pag ganyan, mag-out na lang kayo. Per hour to, so 3,600 seconds per 1 hour. Okay. So, cancel nyo ito, yung kilogram, yung seconds, in seconds. Okay. I-multiply na natin to ng 6.496 times 10 to the negative 2. Okay? Times 3,600. Then, the answer will be 2.111 meter cube per kilogram. Ay, hindi, meter cube. Meter cube per hour. 2.111 meter cube per hour. That is the flow of your refrigerant. That is for problem number 1. Very basic. So, how about problem number 2? A refrigeration system operates on the reverse Carnot. Okay? Reverse Carnot. The maximum and minimum, ayan na, binigay na. Maximum and minimum temperatures, Tmax, is equal to 161.6 degrees Fahrenheit. Tmin is equal to 13 degrees Fahrenheit. And then, the heat rejected, QR, is equal to what? Is equal to 94.79 BTU. Okay. Ang hinahanap natin is the cooling capacity, which is QA, in kilowatts. Ngayon, naka-BTU ito. Okay, ganito na lang yan. Tmax equal to QR divided by Tmin over QA. Okay, ganun lang kadali. Ang hinahanap natin is in QA. Okay, pwede natin balikan kung hindi nyo maaalala. Okay, balikan natin yung sa formula. Let us get back with the formula nung Carnot cycle. Ayan. TL is QA, TH is QR. Pwede magkabaliktad. T high over T low equal to QR over QA. Pwede rin to. Pwede rin to. Okay, so let's get back with the solution ng ating Okay, ang hinahanap natin is in QA. O, algebraically, pwede nating arrange yan. QA is equal to QR multiplied to Tmin over Tmax. Kaya lang, ito bang mga values nito, yung mga values ba niyan, naka-absolute na? Hindi pa po. So, let us solve. Anong kailangan natin? Kilowatt. Ang nakalagay dito is BTU per second. Okay? Kailangan to maging HP muna. Or kilojoule, pwede naman. Oh. So, ang value niya is 94.79 BTU in every second. Multiply natin ilang BTU per kilojoule. So, 1.055 kilojoule in every BTU. Oh, di ba ang kilojoule per second is kilowatt? Oh, sapat na yan. That will suffice. Oh, since pareho lang naman yung magiging degrees Fahrenheit dito, degrees Fahrenheit din dito, might as well wag na nating isama yung kanilang mga units. Pero kailangan i-absolute pa rin natin sila. So, 161.6 plus 460. Timin pala to. 13 lang pala. 13. So, 13, 161.6, 161.6 plus 460. Oh, yan. Pwede na yan. O, di ang lalabas dyan is QA na in kilowatts. Okay, the answer will be, pahabain pa ba natin? Hindi na. Solve na natin. 94.79 times 1.055 divide by 161.6 plus 460 times yung nasa taas, 13 times 13 plus 460. Now the answer will be, yan yung QA, QA. Pero ang hinahanap pala dito, cooling capacity. Cooling capacity ang hinahanap. Tama. So, may kulang dito. Minus 13 pala dapat. Minus 13. So, minus 13. Hindi ko nakita yung minus na binasa dyan. Yun. Minus 13. Minus. So, minus. Ayun. So, 71. That is QA. 71.9138 kilowatts. Yan ba hinahanap dyan? Ang hinahanap din, paano kung hinahanap naman yung work net? The work net, QR minus QA. O, di, ganito lang yan. QR. Yung 94.79 times 1.055 kilowatt minus 71.9138 kilowatts. O, minus na lang natin. So, the work net will be 94.79 times 1.055. The answer will be 28.09 kilowatts. 28.09 kilowatts. So, ano ba hinahanap niya dito? The cooling capacity in kilowatts, dapat QA yan. And then, the work net, kulang lang yung asked. So, that is for problem number 2. How about problem number 3? A refrigeration system is to be used to cool 45 metric tons of water. Okay? From what? 29 to 18 degrees Celsius in 5 hours. The refrigerant is ammonia and the operation conditions are 0.616 MPa, evaporating pressure yan, and then 1.737 MPa liquefaction pressure, that is condensing pressure. Determine the quality of cooling water in the condenser for an increase of 7 degrees Celsius. And daw yung delta T sa condenser. Tapos, HF at condensing, HG at 1 sa evaporator, compressor exit naman ito H2. Now, ano po ang gagawin natin dyan? Simple. I-trace mo muna, di ba? Drawing natin. Meron kang evaporator. Yan. Ngayon yung evaporator mo, meron yung mga cooling coils. Okay? Yung cooling coils na yun, palalamigin nila yung tubig na nandito. Pagpasensya nyo na yung drawing ko. Gagawin niyang, nagbago ba? Hindi. Gagawin niyang yung H2O mo, palalamigin lang niya. This is 28 degrees Celsius water to 18 degrees Celsius H2O. Sinabi ba dyan na nag-change siya ng phase? No. Okay? No change in phase. Ibig sabihin, sensible heating lang yan. Then kapag sinabing sensible heating at constant pressure lang naman, Q will be equal to mCp delta T. At ano nagbigay ng init dyan? O yung refrigerant mo. That is the mass ng refrigerant multiplied to H1 minus H4. Yun yung nangyari sa evaporation mo eh. 'Di ba? At yung refrigerant na yon, equal yan sa naging change ng heat dito sa tubig. Okay? Alam nyo na? So, meron kang binigay na mass ng water. Therefore, lagay natin dito. Therefore, yung heat ng refrigerant mo, transfer mo sa heat ng water. Ngayon, meron tayong mass ng water binigay dito. Ayun, 45 metric tons of water. So, mass of water equal to 45 metric tons per 5 hours. Wala nang problema. Anong hinahanap natin? The mass of the refrigerant. Para makuha natin yung, ano ba hinahingi dyan? Quantity of cooling water. Ngayon naman, dun sa iyong condenser. Nandito yung condenser mo di ba? Condenser. Meron ditong cooling water ka naman. Water in, water out. Dito, yung kinul mo, yung water, gagawin mong malamig na tubig. Sa condenser naman, i-absorb naman nung tubig sa labas ng iyong condenser going out to your cooling tower. yung magiging init ng iyong refrigerant. Okay, let's go. So, mref multiplied to, ano, yung H na lang, H1 minus H4 equal to M ng H2O, Cp of H2O, tapos, ano bang meron dyan? Yung temperature na to, temperature high, temperature high minus temperature low. Now, ang hinahanap natin is mref. Mref is equal to MH2O multiplied to Cp ng H2O tapos TH minus T low divided by H1 minus H4. Now, we can solve for mref. Okay, equal natin ang buo. Ang binigay dyan, meron kang 45 metric tons, so 45,000 kilograms na kagad yun. Ganyan mo na kagad. 45,000 kilogram in 5 hours. Kaya lang, ang measurement natin dito is in seconds. 1 hour is equal to 3,600 seconds. Cp of water, 4.187 kilojoule per kilogram degree Kelvin. And then, yung temperature change nung tubig na pinalalamig mo from 28 to 28 ba yan? 29 ata yun, 29. Ayun, 29. So, tinitignan ko dito. 29 tayo. 29 to 18. Okay? 29, 18 degree Kelvin na kasi change in temperature. H1. Ano yung H1 natin? HG dapat yan. Ayun. 1471.6. 1471.6 minus 410.4 kilojoule per kilogram. Medyo mahaba lang talaga to. Cancel natin yung same units. That is hours, kilogram, kilo, hindi. Ayan, kilojoule. Ito matitira, pwede mo iakyat. Kelvin. Now, we can solve for the mass of refrigerant. That is 45,000 times 4.187 times 29 minus 18. Okay? Multiply natin ng 5 times 3,600 times 1471.6 minus 410. Mas maganda ganyan kayo mag-solve. I-simplify nyo muna. 410.4 para ma-solve nyo agad. So, the mass of the refrigerant, dapat mas maliit yan. So, mref is equal to 0.1085 kilogram per second of R12. Ano binigay ba dyan, R12? Hindi. Refrigerant lang. Refrigerant. Sir, tapos na po ba tayo? Hindi pa. Kasi ang kukunin naman natin yung sa condenser. 'Di ba? Yung condenser mo, okay? Sa condenser, to the cooling tower, cooling water na lang. Cooling water. Okay? Yung heat na meron ka sa condenser mo is equal to the heat na meron ka dun sa cooling water. Oh, panibago na naman. So, meron kang mass ng refrigerant. Ano ba ipapasok sa condenser mo? H2 minus H3. 'Di ba? Pero yung H3 mo, that is equal to H4. Kasi yung H3 to H4, pag simple vapor, that is what? That is throttling, constant enthalpy. Ngayon ang mangyayari, i-absorb naman nung ganyang init, okay? I-absorb niya. nung water mo naman, sa cooling water, CP nung cooling water, yung delta T ng cooling water. Ngayon, ang hinahanap mo diyan is the mass of the cooling water you need. So ito, okey? Diyan ka naman magmumula. So, mass of the cooling water equal to mrep multiplied to H2 minus H3 divided by CP nung cooling water, delta T. Ngayon, mga given naman na 'to, okey? Meron na tayong delta T na ano yung delta T natin diyan? At kundi ayun, 7 increase, 7 degrees Celsius. So, mrep 0.1085 kilogram in every second. Ano bang unit ang hinahanap dito? Per minute, okey? Nakalagay dun sa question. So, H2 outside the condensed ayun, compressor 1620, 1620 minus pareho lang ng 4, that is 410.4, okey? Ilagay natin yung unit, kilojoule per kilogram. Tapos yung CP ng water same lang naman 4.187 kilojoule per kilogram degree Kelvin. And then you multiply that to delta T na 7 Celsius degree or degree Kelvin na lang. Pwede na yan. You cancel all the same units. So, kilojoule, kilojoule, kilogram, kilogram, Kelvin, and Kelvin. At tira is kilogram per second. So, you can now solve for the answer. 0.1085 times 1620 minus 410.4. Yan. Tapos 4.187 times 7. So, probably medyo mataas. Ayan. Ano to, seconds to. Kaya lang gusto natin is in minutes. Okay? Nasa choices daw. So, meron kang 60 seconds. 60 seconds in every minute. Times 60. Diretso. The answer will be 268. Okay? 268.67. 268.67 kilogram in every minute of cooling water. That is the answer. Medyo matagal 'tong mga ganitong problem, kailangan talaga alam mo yung process. Okay? So for number 4, an air conditioning system of a high-rise building has a capacity of 0.35 megawatts of refrigeration. Okay, hindi tons, megawatts yung capacity niya, QA yan. The evaporating and condensing temperatures are 0 and 35. So commonly this can be found on your tables. Pero dito ibinigay na diyan yung value ng HF, nung HG. So yun na lang yun. Meron ka ng H4 and equal to H3 yan. Ngayon yung HG mo, that is H1. Tama? Now, what will we find? Yung enthalpy leaving the compressor, anong hinahanap dito? Parang determine the work of the compressor. Yun na lang. So, paano natin gagawin diyan? Hanapin mo muna yung mass ng refrigerant mo coming from yung total capacity na meron ka. Meron ka daw diyan 0.35, i-multiply mo ng 1,000 yung 0.35 na yan. Times 1,000 mo, okay. Para makuha mo yung kanyang QA. That is 350. Okay, 350 kilowatts. 350 kilowatts yung refrigeration effect mo diyan. So, meron kang QA, mref, tapos meron kang multiply mo nung enthalpy ng refrigerating effect H1 minus H4. Ngayon hahanapin mo tong mref. So, mref is equal to QA divided by H1 minus H4. Okay, you can get used to it naman eh. Drawing ba natin? Ito yung expansion valve mo. Okay? This is your condenser. Condenser yan. This is your evaporator. Tapos dito yung iyong compressor. Compressor yan. Ngayon, this is 1, 2, 3, 4. Ang common dito, H is constant. Okay? Dito, constant pressure heating, constant pressure cooling. Okay? Dito, isentropic work sa compressor. So, that is the simple vapor compression. Now, okay, let's go back. So, QA, anong unit ang hinahanap dito by the choices? Ano ba hinahanap dito? Kilowatts din. So, QA mo is 350 watts. 50 kilowatts pala. 350 kilowatts. Divide by H1. Asan H1 mo? 351. 351.48 minus H4 or H3 equal lang naman yun. 233.5. 33.5 kilojoule per kilogram. Itong kilowatt, multiply mo ng 1 kilowatt in every 1 kilojoule per second. Okay. So, kilogram per second ang patak niyan. Cancel natin yung same units. Kilowatt, kilowatt, kilojoule, kilojoule. Ang lalabas, kilogram per second. So, we can now solve for the mass of the refrigerant. Laging ganun yun. Nawawala yung mass of refrigerant. In order for you to get yung ibang work dyan, tulad nung compressor work and then the condensing heater, condenser heat rejection, hanapin mo muna yung value ng refrigerant, yung mass flow rate. Okay. Solve na natin. 350, 351.48 minus 233.5. The answer is 2.966. Okay. Equal to 2.966. Ako ang ginagawa ko sino-shortcut ko na lang. Kilogram in every second. Paano sino-shortcut, sir? Hindi ko na kinukuha yung buong value. Pero pwede nyo istoryan para mas accurate yung sagot. So, meron ka ng mass of refrigerant. Hanapin mo na yung work ng compressor. So, for the work of the compressor, meron kang mass ng refrigerant. Okay? Tapos, saan galing? H2, H1. O, di H2 minus H1. Oh. Mass of the refrigerant, 2.9666 kilogram in every second. Multiplied to H2. Binigay dyan, 368. 368. Okay, saan po ba lagi nakukuha yung H2? Naka-graph to. Okay, graph. Naka-graph yan. Hindi mo makukuha yan kung mali yung graph mo. Lalo na pag mali ka nag-graph niyan, malayo makuha mong value. So, H1, that is 351.48. Dapat maliit lang yung compressor work mo dyan. Kilojoule per kilogram. So, the value for the work of the compressor is, this is very basic, times 368 minus 351.48. The answer will be 49 kilowatts. Okay? 49.01. 49.01 kilowatts. That is the compressor work. Okay? Very basic in number 4. How about number 5? Tingnan nga natin. A refrigeration system operates on an ideal compression using R12 with an evaporator temperature of -30 and condenser exit temperature of 49.3 degrees Celsius and requires motor to drive the compressor. So meron ka daw work ng motor is 74.6 kilowatts. Sinabi ba diyan yung shaft efficiency? No. So therefore this is also equal to the work ng compressor. Tapos binigay na sa'yo. Condenser entrance, ibig sabihin this is H2. Yung exit naman, condenser exit, this is H4, which is also equal to H3. And this is evaporator entrance, evaporator exit. Okay? Binabi na isa-isa. Ayan na, H1. May problema pa ba tayo dyan? Ano hinahanap natin? What is the capacity of the refrigerator in tons of refrigeration? Again, inulit laang po. Inulit laang. So, ang gagawin mo dyan, you have to find again the mass of the refrigerant. So, work ng compressor equal to mass of the refrigerant multiplied to H2 minus H1. Ngayon, ang hinahanap natin is MREF. Okay? Ipasok na natin isa-isa. Ang hinahanap natin is QA, the refrigerating capacity. So, MREF multiplied to H1 minus H4. Okay, ipasok natin yung value na dito. Algebraically, para dire-diretso ang ating solving, QA is equal to, okay, work ng compressor over H2 minus H1. And then, i-multiply natin ng H1 minus H4. Ayan, pinadali ko na sa inyo. So, the work of the compressor, what we have to do is convert it into tons of refrigeration. Di ba? Equal yan saan? 1 torr is equal to 3.5167 kilowatts. Equal to 4.71 HP. Kung di ako nagkakamali. Okay? Yan lang yun. Okay, so let us solve. So work of the compressor, nakalagay dito is 74.6 kilowatts. Multiply na natin. 1 torr. 3.5167 kilowatts. Divide natin, okay, ng H2 minus H1. The condenser, N3, okay, 382 minus evaporator exit, that is 338.14 kilojoule per kilogram multiplied to H1 ulit, 338.14 minus yung exit ng evaporator, 248.15. Okay. Kilojoule per kilogram. Now, we cancel all the same units. Kilowatt, kilojoule per kilogram, kilojoule per kilogram, natira torr. TOR. So, we can now solve for the value. So, 74.6 divided by 3.5167 multiplied to 382 minus 338.14. And then you multiply that by 338.14 minus 248.15. Now, the answer will be, sa isang pindutan, 43. Okay? 43.52. The answer is QA. 43.52 TOR. Okay? So, for problems 1 to 5, very basic. Okay? Let us take a 5-minute break. Okay?